Welcome back to RamZland. Today I want to show you the rise and fall of sodium. Check this out.
For this demonstration, we're using Gulf wax, phenolphthalein as an indicator, sodium, a test tube, 100 milliliters of distilled water, and my blowtorch. Begin by filling your test tube halfway with water and add a few drops of phenolphthalein. You'll notice that phenolphthalein is clear in the presence of water or an acid. Next, select a small piece of sodium from your mineral oil. Sodium is stored in mineral oil because it reacts with water. Use a spatula to cut a couple pieces that are small enough to fit down your test tube. You might notice that sodium has kind of a gray color to it, but that's really the oxide layer. Underneath that, it has a very bright, shiny luster. Next, break off several pieces of wax that can fit down the neck of a second test tube. You're going to melt these pieces of wax into a liquid. Now with your blowtorch, start melting the wax. Be careful that you don't bring the wax to a boil. Set up your test tube with phenolphthalein and water over a flame blanket behind a blast shield. Make sure that you don't add your wax until it's no longer releasing any kind of smoke that has had a chance to cool, and you're just going to add a small layer of molten wax over your water in your test tube. So there's about an inch of suspended wax over the water.
And now for the most interesting part, you're going to add those small pieces of sodium and let them fall through the molten paraffin. Ask yourself, why does the sodium rise and fall, rise and fall? What's causing that to occur? Check this out.
Okay, here's our first piece of sodium. Here's the balanced equation for this amazing single displacement reaction. We start with the reactants sodium and water. We have 2 moles of sodium, that's 2Na, and 2 moles of water, that's 2H2O. When those combine through that layer of paraffin, we get the products sodium hydroxide and hydrogen gas. We have 2 moles of sodium hydroxide, that's the 2NaOH, and 1 mole of the diatomic molecule of hydrogen gas.
I hope you enjoyed today's edition of RamZland, and I'll see you next time. If you enjoyed this presentation, be sure to remember to like and subscribe.